This is Clinical Conversations. I'm Joe Elia, and my co-host, Dr. Danielle Schurer of the Medical University of South Carolina, is on the line. This time we explore some genetics, specifically how ancient changes to the male or Y chromosome might be related to why men are more susceptible to coronary disease than women. A study examining that possibility appeared last week in The Lancet. Our guest is the paper's second author, Ms. Lisa Bloomer of the Department of Cardiovascular Sciences at the University of Leicester. Thank you for joining us, Ms. Bloomer.
Hi, no problem.
Before we talk about your study, some essential background. The work is based on examination of common haplogroups of the Y chromosome.
Yes, that's right.
Can you give us an oversimplified explanation of a haplogroup, because it's been decades since I took zoology?
Yeah, no problem. In a nutshell, the haplogroups, the Y chromosome haplogroups, are evolutionary lineages of the Y chromosome. So each Y chromosome can be traced back through looking at different mutations of its sequence back to the Y chromosomal Adam. So the very first original human Y chromosome can be then traced down through the analysis of a phylogenetic tree.
In your study, you point to about, I guess there are 13 principal ones.
In Europe, yeah.
In Europe, okay.
Worldwide, there's 20 major lineages with about 200 subdivisions. In Europe particularly, which is what we looked at, there's 13 major ones.
And those are relatively stable. In other words, changes in those are rare because...
Very rare. Yeah, they're very, very rare.
Tell me why they're rare.
Mutations in the Y chromosome generally are actually quite common because of the structure of the Y chromosome particularly. But the Y chromosome mutations which change haplogroups and are maintained within a community are incredibly rare. Because of the way it's inherited intact from father to son, there's no recombination, there's no crossing over of genetic material between the X and Y chromosome. The lack of that means you don't get many changes in the haplogroup tree.
Okay, so it's sort of like the situation in the mitochondria, right? Because in the mitochondria are all inherited from your mother, and those are very stable.
Yeah, that's exactly the same. It's the male version of the mitochondrial lineage in females.
All right, thank you.
And this is Dr. Scher, what got your group interested in researching the question between the link in various types of Ys and coronary artery disease?
Previous work from our group has looked at the Y chromosome in relation to cardiovascular risk factors, so things like lipid levels and blood pressure. So that first got us interested. We also read quite a lot of papers, as you do, and found things like polysomy Y chromosome. So if you've got an extra Y chromosome, that makes you that much more likely to have a cardiovascular event.
Oh, okay.
So the natural connection was there in our previous work that we've looked at.
And you did a couple different things in this study. It was very interesting. For one, you looked at, again, this association between haplogroup I and coronary artery disease in one cohort, and then you confirmed that association in another cohort. Yeah. And then you also examined how RNA transcripts in people with this specific haplogroup might differ compared to those in other haplogroups. And the connection you found, it looks like it is pretty convincing that your risk of coronary artery disease is about 50% higher if you have this specific haplogroup than if you don't, correct?
Yeah, that's exactly it. That was exactly the main finding of our paper.
Even when you adjust for the routine stuff, so blood pressure and weight and all the usual suspects.
Yeah, it came out as an independent risk factor. We sort of assumed, being the Y chromosome, it's always associated only with sex differentiation. It must be acting through something else, like blood pressure, lipids, that have had associations with before. But it isn't. It was completely on its own. If you have this form of the Y chromosome, you are that much more at risk of coronary artery disease, irrespective of all the other conventional risk factors that we know about.
Although before people get too excited about running out and trying to find out what their haplogroup is, you also mentioned that on its own, this haplogroup I would not be sufficient enough to what you call the high positive predictive value, saying that this in and of itself won't necessarily tell you that you will get coronary artery disease.
No, it doesn't. There is no hard and fast rules when it comes to complex diseases like coronary artery disease, but it is a big reminder of how important family history in predicting coronary artery disease really is. Mm-hmm. It brings us back to the genetics is very important in complex diseases. It's not the entire story. There are a lot of lifestyle choices, lipids, that kind of thing. But family history is incredibly important, and that's majorly what it points towards from our paper. Although it can't be used in isolation, it can't be used on its own, it is a big indicator of how important family history really is.
At least male to male.
Male to male, yes.
Yeah.
Yeah.
And then you also mentioned in your paper that this specific haplogroup I is essentially absent outside of Europe. Again, tracing back ancient lineages.
It does.
And that there obviously is some variability just based on, patterns of dissension within Europe. So Northern Europe has a higher prevalence than Southern Europe, for example.
It does.
So having said all that, what would you summarize for our listeners what the clinical implications of this are for patients outside of Europe, if any?
I don't really think there is any, because you don't find this risk haplogroup outside of Europe at all. That's not the way it works with this haplogroup. But again, it does go back to genetics is important. So as a direct result of this paper, for people in Africa and Southern America, you can't really use the findings from this paper other than it goes back to complex diseases do have a grounding in genetics. There will be something that predisposes Africans, Americans to coronary artery disease if you can find it.
If you can find it, exactly.
If you can find it, yeah.
Yeah. You just happen to find it because you looked in this population.
Yeah, we worked very hard to find it, but yes, we did.
Right. It didn't come easy.
Yeah, there's always a certain amount of luck in any kind of genetics, but yes, we did.
Right.
Could I ask, is there a differential risk outside of Europe between men and women for coronary disease?
Yes.
There is.
Worldwide, there is sexual dimorphism in coronary artery disease.
Okay. So the explanation in those other regions where the haplogroup I doesn't exist must be something else then?
Yeah.
Okay.
More than likely, yeah.
You did an analysis of RNA transcripts, and you found that the people with haplogroup I had a number of different kinds of mRNA or different levels of mRNA transcripts circulating around. Can you talk a little bit about that?
Yes. So our transcript analysis looked at about 12,000 genes from the genome and looked at their respective expression levels between carriers of the risk haplogroup and compared to all the other ones. And the biggest finding that we found was a deregulation of the immune system. So we found a number of pathways involved in inflammation were upregulated in haplogroup I, so that these genes had a higher level of expression.
All right. So that would mean then that in the inflammatory state, you would get a kind of a hyperinflammatory state if you had haplogroup I.
Yeah, your basal level of inflammation is that much higher. So when you get challenged by a pathogen or that kind of thing, your inflammation response goes much higher than a carrier of another haplogroup.
And that might then translate into greater risk for coronary disease if coronary disease is in fact an inflammatory process.
Yeah, it is. Yeah. The immune system and inflammation, the change of monocytes to macrophages are quintessentially important steps in the development of atherosclerosis. So that's how we think haplogroup I is predisposing these men to coronary artery disease by increasing their basal level of inflammation.
And you said that the paper says that the transcripts in monocytes were not different among the groups, but the macrophages were very different.
They were, yes. Yeah, we found no difference whatsoever in monocytes. It was quite sad until we realised that the macrophages were so different, their transcript levels were so different. Mm-hmm. And like I say, the activation of macrophages from monocytes is one of the most important steps in development of atherosclerosis. So it makes logical sense that could be where this haplogroup is exercising its effect.
Okay. What's next on the research agenda?
There will be a number of things. First one, as ever, get some other independent groups to replicate our findings. Mm-hmm. Always is the first step in any kind of genetic research. But moving on from that, we want to find what it is about this haplogroup of the Y chromosome that causes this change in the immune system. Mm-hmm. So we've narrowed it down to one type of the Y chromosome, but what is it? Is it a different transcript, a mutation in one of the genes? We want to find that kind of thing. And conversely, do functional studies. So what makes the macrophages different? Do they move across the endothelial barrier differently? Do they move differently? Is there a morphological change?
Huh. Well.
And again, going into the geographical differences, so as you said before, the change in haplogroup I prevalence across Europe, seeing whether there's anything in that. Can we narrow it down further to a certain type of the Y haplogroup I? There's a lot of work to be done.
Yeah.
Because it also doesn't appear in your discussion section, this probably isn't just limited to coronary artery disease, right? I mean, this is an immune system dysregulation. In your discussion section, you mentioned the implications of haplogroup 1 on HIV infection.
Yes, exactly. The overlap between the two diseases was very interesting to us, both, like I say, both immune-based, but a different outcome. So it is possible that this risk haplogroup is so embroiled in the immune system that it can predispose to a number of immune system-related diseases, which is another line of future work. We don't know at this stage. It seems logical. That's why we put it in our discussion. But it does need work in going to go and see, is it an all-encompassing umbrella that you are that much predisposed to
a lot of different things.
A lot of things, or is it specific to HIV and coronary artery disease? And if it is specific, why is it specific? Finding out the reasons for the findings.
That's interesting.
Yeah, lots of science ahead for you guys. Well,
yes.
Yeah, good luck to you, and I hope our paths cross again on newer results. Thanks for...
Yeah, work fast.
Yeah. Yes.
Yeah, hopefully.
Thanks for spending time with us today, Lisa.
That's no problem. Thank you for having me.
That was our 145th edition, and all the earlier ones can be found at podcasts.jwatch.org. We come to you from Journal Watch. Journal Watch's website is jwatch.org. That's spelled JWATCH.org. Clinical Conversations executive producer is Adore Yano. I'm Joe Elia. Dr. Danielle Schurer and I thank you for listening.